MQA Certification UK Limited, presenting Lean Six Sigma Green Belt Training Day 1.
Welcome to this 5-day Six Sigma Green Belt training program. Today is the first day, and we will be having these sessions over the next 5 weekends starting today. So, welcome once again, and I look forward to having a very fruitful, interactive discussions during these 5 days. Now, I'll try to keep this training very simple. Now, you can, yeah, this is the agenda where today we'll have a basic introductions of each of us, and also we'll know each other, our backgrounds, and the structure of the program. What is Lean? What is Six Sigma? And what is Lean Six Sigma? What are the different tools that are used? What is the methodology of the Six Sigma program? And also then look at the first phase, which is the define phase of the Six Sigma model. This is what we will discover today. And then over the next few weekends, the remaining 4 parts, which is the measure, analyze, improve, and control. So 5 Saturdays, and I look forward to this training. We'll have this introduction, like I mentioned, about what is Lean, what is Six Sigma, and what is Lean Six Sigma, what is the DMAIC, DMAC methodology used by Six Sigma, and then what are the different, how do we identify a project, select a project for improvement, and the define phase and the roles and responsibilities. And the output of this phase would be a project charter. That is a starting point or like a roadmap for the entire project. And then how to create a cyborg diagram or map the current process. A few of you have a quality background, have been a lead auditor, and also implemented improvement models. For them, it will be easier to understand at least this phase, because all the improvement models are process models, including this model. They all believe in define a process and improve the process as we go along implementing it. And then when we identify a project, how do we identify the voice of customer? Because for every activity, every process, there is a output given which goes to a customer. And whatever we do is ultimately for the benefit of customer. So what do customers require? What is critical to quality from customers' point of view? And also in the remaining phases, when we look at measure, analyze, improve, control over the next few weeks, we'll look at many more tools like FMEA or Pareto or different types of waste, mistake proofing, etc. So I will try to keep it as simple as possible, as most of you do not have background in this. Now, there is a misconception that all these, the Six Sigma is a highly technical tool which requires statistics a lot, which puts away many people. Although in all these phases, define, measure, analyze, only in analysis phase, we might require high-end tools like Minitab or SPSS. Remaining define, measure, improve, control, these are all tools or phases which require human intelligence and creativity. And for most of these cases, almost 80% of the Six Sigma projects, especially till the green belt stage and also black belt, in most cases, we can use tools like Excel, to compute data to arrive at the current Sigma level and the future desired level, and do some analysis, whatever analysis. So Excel is an excellent, very versatile tool which is used by majority of the people. It's only in very high-end, detailed, large projects that we may we may need to use SPSS or Minitab, because the data points are too many. There are too many variables. But for practically all the purposes with your backgrounds and green belt projects, Excel is sufficient to use for creating or improving our processes. If you have any questions anytime during the training, please feel free to ask. And if you have got experiences or data that relates to topic, it is your session, all the 5 sessions. And all of us, when we discuss collectively, ask questions, give answers, that the things concepts become more clear. And we'll be having a few short breaks in between so that we can recharge ourselves and take a maybe bio break, etc. And please keep your phones on silent mode or buzzer mode so that in case there is a call, you can maybe go out. Although we are not on video on mode, I am sure all of you, because there are network issues, etc. So I request all of you to remain connected and remain online. There could be a temptation because some of you are attending this session from your homes. So there could be some personal work and you may get to go away for a few minutes or a few seconds. So as far as possible, please try to remain online and connected and interact and involve in the activities. Okay, and you may also take your own notes as it suits you. So you have to take part in on all and be present in all those 5 days, and there will be an exam in the end, and the passing marks are 75%. Now, the question is, how do we solve a problem? Or what is a typical approach to solve a problem? In our personal life, in our professional life, in our organizations, we all come across challenges, customer complaints, employee issues, supplier issues, defects during the production cycle or returns from customer, financial challenges. So when you have a typical problem in your organization, in your function or department, what is the typical mindset to approach it? In a very generic way. We may not refer to any tools or technology or anything, but what is our approach to solve a problem officially or even in personal life? What is a typical approach? Think of any example. Okay, let's say in your personal life, you have to reduce your weight. Okay, you think you are little heavier and you set a target that I want to improve my weight and have a better health. Let's take this example. So what will you do? How will you go about it? First, define the problem. Hmm? That means you look at what is the current weight and you look at the challenges you are facing, maybe when you walk or when you go upstairs, then you feel breathless. So you start feeling something is wrong and you have to control it. So having a better lifestyle, better health, that is the opportunity for improvement or a or area that you identify as a problem area. Then once you have identified that I must reduce my weight for a more fulfilling life, then you first baseline. Okay, the first part was definition that I am overweight or obese as per medical standards. Second is, where do I stand now? What is my current weight? What is my current lifestyle? When do I get up? When do I sleep? What do I eat? How much do I eat? How often do I eat? What is my physical exercise? How much do I walk in a day or in a week, in a month? Okay, so that means we baseline our current status. Currently, what am I eating or consuming, or in terms of exercise, what am I doing? So first define the problem, overweight, being overweight. Second is you define the current status. What is my current weight? Suppose your current weight is 100 kilograms and the target is,
Excuse me, Dr. Anurag.
yes.
Is your slides moving? Because I'm still on the first page.
Oh, okay. Okay, I got it.
All right.
Sorry. So then we first define the problem and then look at the current baseline. Where do I stand today? What is my target for improvement? If I am currently at 100 kilograms, Maybe I have to maybe target at 75 or 80. In what time frame? So those kind of, that means baselining and having a measurable way of knowing where we stand today and where we want to go. And then do analysis of the, so define, measure, and then analyze what is wrong. What time do I get up? What do I sleep? When do I sleep? What do I eat? What do I do? No, a whole inventory of your current lifestyle. You analyze, and why is it happening? What am I doing incorrectly? How I can improve it? And then you lead to improvement. Once you have done your you analysis of your time management and the eating habits, then you try to improve. Okay, I'll stop doing this thing. I'll start doing this. I will sleep at 10 o'clock. I will eat my food latest by 7:30 or 8 p.m. in the night, in the evening. Okay, I'll get up early, little half an hour early. I'll go for a walk. So you try to put some improvement actions in place. After knowing this is the problem, this is my target, this is my current status, and this is now the improved part is the actions I'm putting in place to have better control on my life and reduce my weight. So action, the target is identified, root cause analyzed, and then we put corrective actions in place. Now we try it for 1 month, 2 months, 3 months, and then again take a weight. Also in process, see a starting point, midterm, towards the end, we start tracking our progress as per our action plans. If it is improving my health, overall health, my stamina, my general health, my weight, my flexibility, that means I'm on right path. Then I make it a habit. So initially, you may try something, some things may work, certain things may not work. But once you have identified that this is the right model, now this is my current lifestyle. What time I wake up? How much portion of food do I eat? What is my physical activity? All that corrective action you put in place, it has shown results. Then you institutionalize it, make it a part of your normal habit, normal lifestyle. You will not go back to the previous state. So define your problem, measure the current status, analyze the root causes, improve in terms of corrective actions and corrections, and then control. Now you make it part of your regular habit. So this is the model that is followed by Six Sigma. And this is the also model followed by anybody without knowing that they are using Six Sigma. Now Six Sigma becomes a very structured method. Now I may follow all these sub processes in action and which are all in my mind. No, mentally, I know I am doing this thing because it will help me this way, but it may work, it may not work. It may instead of 3 months, it may take 1 year. If you don't see a result in maybe 2 weeks, you start going to gym, you lose motivation. But in organizations, when we want to improve certain things, we make it a very structured methodology where there are proper insights. Who is doing what, when, where, how. And we start tracking our progress. The teams are created, tools are introduced, so that it becomes a very monitored exercise, and we know what is happening, where do we stand, numbers are tools are created, data is collected, etc. So there is nothing, and this is a model followed everywhere in every area of improvement across the models like ISO 9001, 45001, ISO, every process of ISO, every stand of ISO or CMI, they all have underlying same process to improve. ISO talks about plan, do, check, act. Plan your work, perform the activities, check for any deviation, and then initiate a corrective action, PDCA. So this is a normal cycle of continuous improvement. In Six Sigma also, we pick up a project which has a defined scope and boundaries. We bring in some improvement, and then we hand over the new process, refined process, to the people who are working on the ground, because a special team is created, a special task force for executing a Six Sigma project. And once we have tried various things, done root cause analysis, changed the process, and saw that it is working, as a test case, as a pilot case, then we revamp or change the original process and introduce it organization wide. So that is a control
Excuse me,
phase. Yes,
are we still on slide 7?
yes, you're right. 2007 only. Now it is 8.
Okay,
So I
please.
was giving a general background of that continuous improvement is a very common sense thing. It is not rocket science. When we introduce a small change in a personal life, everything is in our mind only. Everything is in our mind and on our hands, on our tips, and we know what we are doing, what improvement we are bringing in our life. But when we work in organizations, there's a lot at stake. We cannot introduce a change or a improvement just for the sake of it, or which is unstructured, uncontrolled, unmanaged. That is why models like Six Sigma help us in making a huge improvement in any area of our working. And it is a very systematic approach where their tools are introduced and used as appropriate, and the formats are created where the top management, middle management, everybody who are concerned, they have a visibility into what we are doing. When we talk of Greenbelt, they are mid-sized projects, not very high-end, very large-scale projects. Large-scale projects, which are company-wide, they are handled by the black belt uh, experts, but for which are organization-wide, which may involve multiple departments, whole organization, even suppliers at times. But green belt are typically mid-level projects handled by people or small teams within a certain function or department. So at each level, there are appropriate tools which can be used. So there are more than 200 tools which can be used, which have been used in the past also. Gemba Kaizen, uh, 5S, Pareto diagram, they have been used otherwise also. But when they are included as part of a roadmap, we know at what stage what tool is being used. And the master black belts or black belts, they are introduced to much more sophisticated tools because the scope of their work is very large. Lean Six Sigma is a business improvement or a continuous improvement methodology to systematically improve processes by eliminating defects. See, the goal of any business is consistency. If we are able to continuously implement a process or follow a process or execute a process repeatedly, exactly same time, same way, with the same output, that is the goal. Because that brings in predictability. We can predict what is going to happen. But if there is a variation or deviation from the expected output, then there is a cause of concern. Then the defects are created. Then delays happen. In a normal life cycle, there is no defect. There are no delays. There are no people issues, no raw material issues, no supplier issues. Then every time, every person is doing things right the first time, every time. But that is not how the world functions. There will be some variation, some normal variation, some special causes which cause variation. You come from your home to office every single day, but you may start at exactly same time, but you will not reach office on the same time every single day. There will be a difference of couple of minutes. Either you reach early because of less traffic, or sometimes you reach much later because of traffic or some road block. So there will be a natural variation in every single case, which can cause deviation. The question is, if there is something which can cause, there are special causes, how do we handle them? How do we control them? How do we ensure that there is a minimum disruption so that customer always gets what they expect? No matter how much road traffic, how much or roadblocks, whatever, we are always able to reach on time, no matter what. Within the expected time, between 8:55 and 5 minutes past 9 o'clock. So Lean Six Sigma is a term used for that broad methodology used to improve processes, increase consistency in delivering to customers or having internal targets met most of the times. There is less deviation, no variation at all. But there can't be zero variation. Something has to be there because we are living in a real world. The suppliers may give incorrect data or raw material may be bad. You know, people may get sick. They may mentally be somewhere else, which may cause some defects here or there. So it is normal part of life cycle. So in a normal life, normal curve, we expect some variations within a certain range, 5% plus minus here. So it consists of two methods. When we say Lean Six Sigma, one is Lean, second is Six Sigma. Six Sigma we have spoken about is DMAIC, which is for process improvement to ensure that people follow processes consistently with minimum reduced variation. If you go to a restaurant to eat food and every time you go there and the taste is different, then their brand does not develop. Branding happens about an organization or a quality of a product when there is a consistency in quality, consistency in the output. And output is only a function of inputs and the process. If we follow the same process, same inputs, the output would be also almost same every time. So to ensure quality products or service as an output, we have to ensure that the underlying process which creates this output is also quality and controlled. So this is first part, increased focus on reducing process variation so that we have a consistent quality or output. And second is lean. Lean is means without any fat. When you say the person is very lean, mean, that means no extra flab, no extra waste, nothing, bare bones, total muscles. That is lean. So lean focuses on waste reduction. Six Sigma focuses on variation reduction. So that we are following the process exactly, almost exactly as it is supposed to be followed. Because if the process is same, the output is also same. Garbage in, garbage out. If we consistently follow a certain process, we can be assured of a repeatable and predictable output. And all the improvement models are process improvement models. Every single model in the world, a continuous improvement model is a process model. Define a process, train the people on that process, let them implement it and keep monitoring it. If something's not working, keep fine tuning the process so that we are moving in the direction of zero defects. Nothing in the world can be zero defect. Okay, it's only a notional goal that we have to strive to be zero defect. If we say 0.00000 100 zeros and one, that possibility of that 0.001 is percent is always there because things in the environment in the world are not static or exactly same. So for all practical purposes, when we say we have achieved a Six Sigma level quality, we know what it is. It means 3.4 defects in 1 million opportunities of creating defects. It is almost world class, almost zero defect. And we say this is good enough. Because if we want to become better, the resources required, money required, effort required is too humongous. It is not worth it. It's like spending $1,000 to save 1 penny. So it is not worth it. So we strive to go from 2 to 3 sigma, 3 to 4 sigma, 4 to 5. And if you reach 4.5, 5 sigma, it is very, very good. It is very, very good because not every company, not every organization or a process will need to go for Six Sigma level because the cost is too much to go to that level and the investment is too high. So first is Six Sigma is reduce the variation in processes implementation. Same process is followed, same output. Process is input and the output is the product or service. So if we control the process variation, we can ensure better quality of the output. And then lean is on reducing the waste. Waste, we'll see what are the different wastes, like waiting for something to happen, or overproduction or defects. So we will see what are the waste. So here in Lean Six Sigma, we are clubbing these two methods together. Lean is reducing waste, and Six Sigma is focusing on variation reduction. And since we are going in the right direction, we want to ensure it is measurement-based strategy. If I have to reduce my weight, I put in some controls in place. I start walking daily. I doing some small exercises. I reduce, control, monitor my food content. But if I don't take my weight, how do I know whether it is improving or not? How do I know whether it is working or not? The activities that I've put in place. So before and after, and also during, if we take a measurement of my current weight, target weight, after 1 week, after 1 month, 2 months, 3 months, if I don't start taking the measurement of my weight, I will not know whether it is working or not by the right pace. So measurement gives you control, it gives you evidence that actually your idea is working on the ground. And the focus is on reducing variation and reducing the waste. Sigma is, so one is that it is a process. Six Sigma is a process or a method for improving our areas which need improvement. If you are following DMAC methodology, you are implementing and following Six Sigma. Second is Six Sigma is also a number. Sigma means deviation or standard deviation. So how many deviations around the mean you can fit in? If you can have Six Sigma means you can fit six times the deviation in a normal curve within the customer specifications. We'll come to that. See, if you do not understand certain concepts, today's day one, it is okay because some terms will be new to you. In fact, most of the terms, so it will take some time for you to get it in your mind. But the target of Six Sigma is 3.4 defects per million opportunities. If there were possibilities of 1 million uh, possible defects, then out of that, how many defects actually happen is 3.4, which is too humongous. Now, lean means let's remove the annoying time wasting steps, waiting for 3 signatures when I will do one will do, or walking to a printer 10 times a day. We are doing so many things which are repetitive, which are time wasting. You fill a form for getting insurance policy, it will go to one level, your boss will see it, then it will go second level, third level, fourth level, regional office, head office. So it will go through multiple stages without adding any value. Once your boss has seen it, verified it, the next higher person will only see it, okay, whether two people have signed it, he'll also sign. Then the next higher level. So no value is being added. The data has got captured when the form was filled by the insurance agency representative. You wanted an insurance, the guy comes to your house or office and you fill the form. Thereafter, the people higher up in the chain, they only just keep signing it without applying their mind. So that is lean. Why do we have 3, 4, 5 steps which are not adding any value to the whole cycle? That is now like lean. Same for Six Sigma. The idea is to do it right the first time and every time without any deviation. That means we ensure that, like in earlier we had typewriters. If you type something, you have to scroll back, delete it, no, put a cross line on that, then again go forward. So once a mistake is made, it is made. It will be visible as a word or a letter on which you have put a cross. But on computers, we have the Grammarly and other online tools, AI-based tools. As you start typing, they will correct it. Or they will tell you this is the right word, this is the right spelling, right grammar. So when we say Six Sigma, we try to make sure that things go right every time. There is no variation, no change, never. So combined goal is do things faster and better. Better is Six Sigma. You are following a process. If the process is creating defective products 10% times, but you are at least following it. If your target is 10% defective maximum, you are achieving it. That means you are Six Sigma because the process compliance is 100% same. But when we say lean, we say no, when we do follow a process, please also make sure that apart from no variation in the process, good output, it also is efficient using least resources. So the extra wasteful effort or time or money is not there. The both effective and efficient. Effective in meeting customer goals. Efficient is that meeting the customer goals with least amount of resources. But this started sometimes in 80s by Motorola, as a model. They evolved it, and later on, multiple organizations, GE, Allied Signals, different industries, finance, education, government, everybody has picked it up and they deploy it at least as green belt in their own organizations, small departments. They have started exploring it. But Motorola was the first organization which actually started implementing it. So IBM, DEC, ABB, Kodak, Allied Signals, GE, look at the list of organizations. So every year it has been increasing and they have it has led to huge improvements uh, in money terms. Ultimately, business is about saving money. Any business is about saving money and by doing whatever they can do, by avoiding any wasteful expenditure, by reducing cycle time, time to market. So it's in the benefit of the organizations that they can uh, be their best. So lots of benefits of Six Sigma, like reducing variation. No, we want we expect predictability in our lives. We don't want that every day when we go to office, by we start going by different routes just for adventure sake. Or when we go to office, boss will their behavior is unpredictable. We want stability in life. We want consistency. That is the normal human behavior. So for that means we don't want surprises. We have seen the recently in the war between Iran and Israel plus US. So lots of unpredictability based on the statements and tweets by the US president. So every single statement of his and his actions that has caused so much unpredictability and chaos in the whole world. So people want stability, the world to be same when we get up in the morning, think no, everybody is around in the family. We get up, get ready for office, come back. No, simple, stable life. People do not want all those chaotic, messy, unpredictable situations. So that is the goal of Six Sigma and benefits it brings in is reducing variation. Okay, reducing any of those surprises, and then reducing cycle time. See, ultimately, when we look at customer, the first or the second most important thing in terms of quality is receiving the product or service on time. The first is when you buy a product, what happens? What do you see? It is the look and feel, the packaging of the product. That is the first thing people will see. How does it look like? Is it broken or damaged? The box is damaged, broken, dusty. The first indicator of quality to people or customers is the packaging or the look and feel, visual communication. And then the time, the delivery time. Okay, what time was committed? Has it been delivered as per that time or not? So cycle time reduction is one goal where we want to reduce the time to produce and time to deliver to customer. Earlier, I know in our country at least, practically everywhere, we used to have tailors. So we will buy clothes from the market, take them to the tailor for stitching, and they will stitch them as per our dimensions, size, height, weight, etc. But today, everywhere, people prefer buying ready-made clothes, ready-made garments. People don't have time, you know. So they will adjust in terms of fitting and all, but they want to save time and effort in buying a cloth and then going to tailor, getting a stage 10, 15 days wait time. People don't have the patience. They want things immediately and in as soon as possible, time in as short time as possible. So reducing variation as an organization, reducing cycle time, time to market, time to produce. That is why we outsource work to external parties. We buy ready-made products. They're reducing defects, whereas it goes to customer, reducing cost of production, increasing market share, increase customer satisfaction. Have a cultural change in the organization where everybody understands this model and they start working. It's a mental approach, a very scientific, structured approach for improvement, and it helps in product development. Now, when we say Six Sigma, there are two models. One is DMAC, we've spoken about, when an existing process is not working or you want it to improve. Second is DFSS, the design for Six Sigma, where when we are creating a new product, launch a new service in the market, then we can use a DFSS model for launching that product, DM and DV. That is different model. But 99% people use DMAC as the default Six Sigma project. So it can be used to fix the current problem or create a value adding proposition to a new product which you want to launch to minimize the defects and have the best possible process from day one to reduce resource consumption, yield, productivity, etc. So these are all benefits of Lean Six Sigma. So when we look at areas for improvement or target projects, we look at possible areas where we can reduce cost, reduce time, or reduce or increase customer service, reduce defects. So lots of benefits of Six Sigma. And when we look at the comparison between Six Sigma projects and non-Six Sigma, now when we say our quality is 99%, that means 1% defective. So when we have 99% versus Six Sigma, which is 99.9997% quality or hitting target on time. Now 99.999 is also called 5-9 quality. So if the quality level is 99%, which will mean more than 100,000, 10,000 newborn babies are accidentally dropped by doctors and nurses each year. That means 99% quality. And if you look at Six Sigma on the right side, less than 38 newborn babies accidentally die every year. Okay, from 110,000 to 38, from 99% to 99.9997%. That is the level of improvement where Six Sigma brings. No electricity for 85 hours every year. No electricity for 9 minutes in 5 years. So every year it have hours of zero electricity versus just 9 minutes of no electricity in 5 years. Look at the quantum or huge improvement. No TV network transmission for 64 minutes per week. No TV transmission for 11 minutes in 10 years. So where it is 64 minutes per week, it becomes 11 minutes in 10 years. Then the 4 short or long landings per day. When the aircraft land, they may land maybe on average 4 times in a day, short landing or long landing. Compared to that, Six Sigma means 1 short long landing in 2 years. So from 4 in per day to 1 in 2 years. Then 16 railway accidents per day at 99% accuracy level to 2 accidents per year. So 16 per day versus 2 per year. 16 minutes per week of unsafe water supply to 1.4 minutes of supply, which is unsafe every 5 years. So when we now we can't implement Six Sigma in every case. We don't even want to or can implement Six Sigma where it is not value adding, it is not worthwhile. Because implementing a project means cost, time, people get involved. The whole team will be given an opportunity to spend a few hours every day on this project for a few months, which is time away from work. So it is not practical to go for or target Six Sigma quality in every single case. If you go from 2 to 3, 3 to 4, 4 to at best 4.5 or 5, that is much required. It is good enough. In fact, very good enough instead of going for Six Sigma. If you are at level 3, strive for 4. And in the process, one will get lot of benefits. Because the gain is not there if we go strive for Six Sigma in every single area of our life or work life. Now, at a rating of 2 Sigma, there are 308,537 defects per million opportunities. If the possibilities of 1 million defects, out of that 308,537 actually happen. At level 3, 66,807. Level 4, 6210. Now, out of 1 million, you got 6210 actual defects. At level 5, 233. So between 4 and 5, 4 ideally, if you are at 4, maximum 4.5, 4.2, 4.5, 4.6, or maximum 7. Beyond that, the input required, the cost or effort required is too high and the benefit is not that high. So there is no point in going for Six Sigma or Five Sigma also. We see where we are today. Set target for improvement 10%, 15%, 20%. And that should be reasonable enough. On a scale of 1 to 10, if you're currently at level 7, you can strive to be 8 out of 10, then 8.5, 9. As you start inching towards 9, 9.5, 9.6, 9.7, the effort and time and energy required is too much. If the base is low, if your weight is, let's say, 100 kilograms, to target 5% improvement, 95 in 6 months is 3 months, reasonable. You will get it. If you're already 50 kilograms, you want to reduce 5 kilograms, it is too difficult. So as we strive, we start reaching towards zero defect. The time initially it is easy and like low hanging fruits. But as you start reaching that level of improvement, then even small percent improvement will require too much effort and cost and energy. So this is what it means that follow the approach. My point is follow the approach suggested by Six Sigma and set those targets. Don't strive for Six Sigma every time. So those are much larger projects and require much larger commitment and investment, which is not worthwhile. So in your own departments, in your functions, pick up green belt projects, which are under your scope, and you can manage them with the current activities. And if you go from 3 to 3.5, 4 Sigma, 4.5, which is good enough. Basically, the approach is to be followed, which is a measurement-based improvement. In other words, if we see at 2 Sigma, it is 3.5, 308, 537 defects. 3 Sigma, 66. Now look at the bars, the colorful bars. So from 3 to 4 is huge improvement. 4 to 5, 5 to 6, 233 to 3.4. That is the ultimate goal. And many and very few organizations in the world actually achieve Six Sigma. Very few. But those who do, they reap lot of benefits. Huge multi-billion dollar improvement, multi-billion dollar savings. So Motorola, GE, giant organizations, they implement black belt projects, that too 1 or 2 projects in a year. Okay, in a year, 1 or 2 black belt projects. But what they inculcate as a culture, as a habit in the organization is follow this model, follow a structured method for bringing in quantum improvement, large improvement in the identified project, in the identified process. That is what they want to implement in the organization, bring in as a cultural change. That people don't just make a small change or small improvement gut feel based on gut feel or perception. Whatever improvements that comes in is method is as per a method and based on measurement and is controlled, and it leads to actual improvement to the customer. That is why the voice of customer, VOC, is to be looked at, that who is the customer, what improvement do they want. We don't make any improvement just for the sake of it. If it is not tied, not adding any value to the customer, the customer will pay us money. If they find that we are delivering better quality of products, better, much more effective, efficient service, then they will give us more orders, repeat business, good reputation. So think of things from the customer's point of view. Will he be willing to pay extra premium to us if we deliver this value? Can we reduce the cost of production by following this model so that ultimately we are saving money, improving time to market? So it all starts with the who is the customer and what do they want or expect. A 3 Sigma hospital would lose 66,807 patients per million due to medical errors at level 3 Sigma. Now, can they afford it? What will be the reputation, legal cases, social repercussions if you start losing so many patients per million due to medical errors? So wherever there is, it's a question of life and death, or it's critical spaceship goes into, I mean, satellites, launching satellite in the space. There it is. We actually have to follow Six Sigma kind of quality where we don't want to leave things to chance. Now, these are some definitions. The unit is the number of parts or sub-assemblies or systems inspected or tested. Now look at the four boxes, these four blocks, the four squares, the four units we're testing. Now within each unit, when we test, we look at 5 dimensions. Let's say you are testing a mobile phone. And when you are testing it or inspecting it, you look at the height, the length, the width, any scratches on the screen, etc. So let's say there are 5 different criteria on or parameters around which you test the product. And the red circle denotes defective. So in the first, let's say in the first square, the first unit which you tested, out of 5 possibilities, 5 parameters which you checked, 2 passed, 3 failed. In the second sample we picked up, 4 were defective, 1 was okay. In the third, 2 were defective, 3 were okay. In the fourth, all 5 were okay. So 4 units that we checked, and in each of the units, 3, 4, and 2 and 0. That was the possible defects that we got. So in total, in all 4 units, there were 5 plus 5 plus 5 plus 5, 20 possibilities, 20 possible defects, right? 5 in first square, 5 in second, third, fourth. So total 20 possible defects were possible. And out of which 9 were actually defective, right? So 9 by 20, that is the defects we got. So now look at the defects per unit. Is the defects number of defects were 9 total out of those 4 squares. Okay, 4 units checked, total defects were found were 9. Total opportunities for defect was 20. It was 5 in each square into 4. possible opportunities of defective, let's say on their mobile phone, all the 5 checks failed. Okay, in all those 4 units, 4 samples we picked, suppose all the in all those 4 units, everything failed. Okay, that would be 100%. So here we are saying the possibility total opportunity of failure was 20 because 4 units and 5 parameters. Defects per opportunity are 9 by 20. Actual 9 were found defective out of possible 20 defects. So if we multiply it with 1 million, we get a defects per million opportunities. Number of defects found per actual maximum number of defects possible into 1 million is the defects per million. Very simple. Just like when we compute percentage, you know, and we've got numbers, 2 students failed out of 10, right? Into 100, we get how many percent students failed, which is 20%, 40%, right? 40%. 2 students out of 10 into 100 is 20% failed. Similarly, here also 9 defects out of maximum possible 20 defects into 1 million is defects per million opportunities. So this is a metric that will always compute what is the DPMO. So when we said 3.4 defects per million opportunities, if there were possibility of 3.4 million defective, and out of that, how many are actually found? 3.4 out of 1 million. That is the best possible case in Six Sigma. So when we try to compute these sigma levels, we try to look at what is the current level and after improvement, what is the new level we have reached. That means we have tried to reduce the defects from current state to future state. Now think of a chocolate manufacturing company which wants to calculate the sigma level for the chocolate manufacturing process. They identified that every day they produce 100 boxes of chocolate with each box carrying 50 chocolates each. Now look at it. 100 boxes means 100 units. Okay, in the previous slide we saw those squares, right? We saw those squares in the previous slide. So here we are saying they are producing 100 boxes each. 4 square means becomes 100 boxes, 100 such squares. And then in each of these, there are 50 chocolates. That means 50 possibilities of error. Suppose each chocolate in that box is defective. That means there are 50 opportunities for defect in one unit and the total units are 100. So total defects per unit are, now compute this. Try to compute the process sigma value or compute DPMO in this. Take 5 minutes. Okay. Okay, take 6 minutes from now and try to compute the defects per million opportunities for this case. 6 minutes from now. See, the total opportunities were 100 into 50 because there are 50 chocolates in each box and there were 100 boxes of chocolate. So there were 5,000 opportunities and 50 defects. So defects per opportunity is 50 by 5,000. Because actual defects were 50 out of all possible 5,000 defects, which is 0.01. So defects per million opportunity becomes 10,000. 0.01 into 1 million, which is 10,000. Now, if you look at the Six Sigma rating, at 3 Sigma rating, it is 66,807. At 4, it is 6210. That means it has to be slightly less than 4, which is 3.82. So the current sigma capability or the process capability of the chocolate manufacturing company is 3.82, slightly less less than 6210, which is about 10,000. So total defects divided by the total opportunities or total possibilities of defects. Since there are 50 chocolates in 100 boxes, total 5,000 opportunities or possible defects. And out of that, 50 are found. So 50 by 5,000, 0.01 into million is 10,000. So this is the way we try to compute the current level and the improved level after improvement. The current status is 3.82 sigma of the defective.
Please kindly elaborate on how you get the 3.82.
See, there is a whole table, which we'll see in the next session from how we can compute the 3.82. Okay, we'll see that in the measure stage next week. How do we compute the sigma level? And we can use it in Excel or online using ChatGPT or Google. We know this is the DPMO. So what is the sigma level? Straightforward computation. And we will see next week how to compute. It is straight away
Okay.
mathematical formula. Okay. So there is question of effectiveness and efficiency. If we are following the process 100% right all the times, that means we say we are effective. If we have to deliver a project to customer in 10 days and we are always delivering in 10 days, we say we are effective. But if we, while doing this thing, while delivering in 10 days, if we reduce the cost of production, then we say we are also efficient. Because the current process may not be very efficient. It is working, people understand their roles, they are competent, raw material is good, and the process is meeting its target. But while doing so, are we also making sure that we are using least cost of production, less manpower, less raw material, less money, less effort, less time? That is the combination of being effective also and also being efficient while we meet the customer's goals. That is what the Six Sigma is all about. Improved accuracy, reduce complaints, reduce cycle time, and reduce rework, reduce cost per transaction, reduce time taken for each activity. So these are twin goals that we look at when we implement Six Sigma, Lean Six Sigma. And there are hundreds of tools available. They have been there in the past also, QFD, which is quality function deployment, or ARMI, or SPC, DOE, design of experiments, critical to quality, scatter, Pareto, hundreds of tools. So as we go from yellow belt to green belt to brown to black, etc., we start getting to know or work on more sophisticated, complex tools. That is the only difference between green belt and a black belt. That the kind of projects we do and the kind of tools we work with. But the model DMAIC, DMAC is exactly same. Same 5 stages, same approach. It's only because of the nature of the products of projects is very, very high end and complex. We choose high end sophisticated tools like Minitab. That is the only difference. Otherwise, model remains same. So Lean Sigma, we know at each stage of green belt what tools are typically used. Like a QFD or Pareto or histogram, we know which tools are generally used, and we'll go through all of these tools over the next few weeks at each stage. But defined stage requires some tools and some outputs, like a cypher diagram or a chart, project charter or tracking sheet, etc. So today, for the defined phase, whichever tools are required or templates are required, we will look at them. And so on for each of the remaining four stages, which is measure, analyze, improve, and control. Now look at this beautiful diagram.
Dr. Anurag, I think we have raised hands. Maybe you can
Yeah,
attend to
also.
that.
Actually, okay, yes, Roberts.
It
Your
was the
hand was
previous hand. Let me
okay.
deactivate it.
Okay, now we'll lower it. Actually, when I show the screen, only screen is visible, not the. Okay, look at this concept. Let's and so now we look at some concepts or typical, the definitions of some terms we use in Lean Six Sigma. Now look at these two diagrams. The pilot, the two lines, two black lines in the first case, and the bottom line. These are the boundaries of the runway on which flights take off or they land. Okay, these are the runways. In the first case, the pilot lands within the boundaries of the runway. Okay, within the two boundaries, the pilot will always land the plane A1, A2, A3, O4. These are the places where the pilot lands within the control limits or the runway limits. Okay, so no deviation practically every time he lands within the desired limits. In the second case, again 10 consecutive times where he lands on the runway, but look at the scatter. The first case, it is scattered all across between those runway boundary during the 10 consecutive runways. So which of the two pilots will you prefer to fly with? First, A or B? Which of the B?
Pilot B.
Because he is always hitting the mean, the center of the runway. Okay. Whereas in the first case, the guy is always deviating left, right, sometimes above, sometimes right, sometimes left. So he's deviating, although within the limits. But the second one is much more efficient, much more effective. He is always bang in the center. So in the worst case, there would be small deviation once in a while. He would go slightly left, slightly right, but that does not happen. Practically, all the flights centered in the runway. So that is what we want. This is all Six Sigma. The boundaries of the runway are the lower specification limit, LSL, and the upper specification limit, USL and LSL. So while these are given by customer, okay, the lower limit and the upper limit, the two boundaries are given by customer. So while you are delivering within that range, it is okay. But the better thing is to always deliver on the targeted. Target is, let's say, the customer says, give me in 10 to 12 days. 11 is the target date and plus 1% 1 day minus 1 day. Okay. The customer wants you to deliver the goods on the 11th day and he says, okay, 1% 1 day here or there, I am okay with that. That means deliver either 1 day before or 1 day late. I will take it as delivered on time. Your target should always be 11th day. That is what customer has said. Although he's okay with that small margin of error or tolerance limit, but the target is always 11. He has said, okay, fine, 1% 1 day here or there, I understand. This can be possible because of various reasons out of your control. So I am okay with that. But target is 11th day because he'll make arrangements for your product to reach, to install it, to make space for that. If you reach early, he will adjust. If you reach late 1 day, he will adjust. So that is what is Six Sigma all about. Six Sigma, not lean, Six Sigma. Always target the mean between the upper and lower limit, which is the center of the process. So we strive to go from pilot A to pilot B, from the first diagram to second diagram. Initially, there is a lot of variation, or we call standard deviation around the mean. Mean is the center of the runway. A small deviation here or there, and that is what Six Sigma is. Some deviation, try to reduce the deviation, reduce the variation, so that you become pilot B. So in a nutshell, This is the entire Six Sigma concept in this diagram. And that is what we strive for, to always hit the mean of the process. So all the first is also okay, but it is not the desired, because small slight deviation further, and we have customer defects, and we have accidents like this. No, we have accidents actually during landing and takeoff because of short landing or no, far landing. The pilot is not able to see the runway because of weather conditions, or maybe some other oversight, or maybe malfunction of the landing gear, and they will overshoot and they accidents. So this is the Six Sigma in nutshell. Reduce the deviation or variation between around the mean, and that is what we strive for and try to improve. So there are two sources of variation: the common causes of variation, which are always there, which are predictable, and they have a natural pattern, and we can't control them fully. We can try to reduce. When you go from your home to office, you leave at home at exactly same time. But when you reach office, could be 2, 3, 4, 5 minutes here or there, because there was a traffic, there was some obstruction. No. So these are always going to happen. Some noise in the system, which you can't control, but you can try to reduce by leaving early. Because target is not to leave on time. The target is to reach on time. Okay. The target for you is to reach office on time at 9 o'clock. It is not whether you start at 8 or 7 or 6. You may start, if you know it is a 1 hour journey, you will typically start at 8, and you may reach at 9, you may reach at plus minus 5-10 minutes. But target is always going to be 9 o'clock. So instead of 8 o'clock, you start at 7:45. So even if there is a small deviation, a small issue on the road, you still are there before or at by 9 upper limit. That should be the target. And then there are special causes of variation. These special causes are out of control. They come as surprise, sudden roadblock, or major accident on the road. We can't do anything about that. So those are special causes of variation. So the common causes we try to reduce, which are known to us. Now let's see again, through some examples, these two things. The common cause is the natural, inherent, and expected noise within a stable process. When we eat food in the house, sometimes food is okay, the taste is okay every time. Sometimes there will less salt. Sometimes our maid puts extra salt once in a while. So that can be expected. Maybe the quality of salt is not good, or the cooking process, or her maybe if she is mentally busy somewhere else. So those are small variations which will always happen, like slight daily traffic fluctuations. While special cause is an unexpected, assignable, and unusual disruption. Now, common causes require system level changes to reduce, where special causes will require immediate investigation and action, which are outliers. If you look at a normal curve in the on a graph, it will go fluctuate plus minus between the mean. But there is a certain spike, that those spikes we have to control, and we have to take action there and then based on the root cause. We can't predict that this will happen. So common causes are stable, predictable, 85% of problems, and they require system redesign, where we look at during the Six Sigma. And special causes are unstable, unpredictable problem which can happen, like Donald Trump, the US president. He is a special cause. The world was going smooth, normal, whatever policies of flip-flop, 40% tariff, 100% tariff, 200% tariff, morning something else, evening something else. Totally unpredictable. His statements and his behavior is totally unpredictable. Now, before he came, things were world was going largely smoothly. Small frictions here or there between countries, between duties being imposed, etc. One-to-one, small of cases, it was happening. But suddenly something comes up out of nowhere and creates cause, chaos. So you can't plan for them. Now, when it has happened, we are trying to deal with it. Those are special cause, which will not happen daily. So you can't say, every 3 years or every second president of US will behave like this. So these are all special causes, whereas the common causes are boundary issues or tariff issues, etc. When Corona happened, the COVID in 2021, that was a special cause. The world could not have predicted or expected this will happen, which will impact the entire world. Just like this time, the oil crisis has impacted the entire world, not expected. So we have to now deal with them as they happen. There are some more examples of no hand raised. I was taking, okay. Some examples of common causes and special causes, like minor material variation. We expect in the raw material that we get powder or other component, metal thickness or density, because they are exposed to natural elements, heat, dust, temperature, humidity. So they will cause small, very minuscule 0.00001% damages or impact on the raw material that no one can control. In ambient conditions, fluctuations in room temperature or humidity affecting machinery, inherent vibrations, small, normal. We say white noise in the background. Some vehicles, some maybe AC, some cooler, some noise. That also is a constant you cannot control. Then human variation. People may behave erratically. I was coming to office and I had a small minor possible accident. Just in time I stopped, applied the brakes because the person in front of me, he applied the brakes suddenly and I also had to apply the brake. Luckily, no one was hurt or the vehicle was damaged. Luckily. But that was playing on my mind. That incident, a house, close it was an accident to an accident. It was a close shave to death or injury. So that is playing on my mind. Mentally, I am still restless, and that will play in the work atmosphere also because my mind is somewhere else. I'm still thinking of the accident while working normally in the organization. My mind is still going back to the morning incident. So that can also happen. So even the experienced, mature operators, based on family issues, somebody not well at home, so mind is occupied at home. Or somebody has to go and pick up somebody. So those things also play on the human mind. So human beings or raw material or machines, they all will have some natural tendency to be to variant. Then process noise, normal traffic delays or small variations commuting time. So these are all common causes which can cause problems. And then there are special causes like machine malfunction. Suddenly machine breaks down or your car clutch breaks down or brake fails. Incorrect settings by the machine operator. These are all possible and they do happen. Whenever a large scale accident happens in the workplace, in some industry or organization, some accident on the highway or explosion, when the investigation is done, it generally comes down to some human oversight. A person was negligent, maybe he had not slept for 2 days, he was too sleepy, if it caused accident, maybe there was a short circuit, nobody noticed, or the fire alarm didn't work. So many, sorry, or so incorrect settings because the mind was occupied somewhere else. unusual raw material, a batch of defective, wrong, contaminated materials, operator fatigue or error, external interference. Yesterday I was in India. There was this case in newspaper where there were two patients of the same name, almost same age, admitted in a hospital. Beds were also nearby. Look at the strange coincidence. Same name, similar age, and also admitted in the same ward. One had a tumor, sort of a surgery to perform. The other had totally unconnected surgery to perform. Both were surgery patients. So they operated on the wrong patient. Somebody and the patient died because of this confusion. And the doctors also, nobody in the system, they realized what they were doing. So they operated the wrong person for a complex surgery. And as a result, the person died. So things can happen. This is a special cause. Okay. Many things, many coincidences, they all happen together. In one case, I remember 2 years back in a hospital, instead of operating on the left leg, left knee, they operate on the right knee or the right leg. When people become absent-minded, something happening maybe in the family front or some accident or somebody, some death in the family, mind is lost, is somewhere else. Special cause. So in that mental situation, the person operated on the wrong leg. So there can be a severe weather event like Corona or COVID, which also, by the way, is predicted in the next couple of years. Something worse than Corona or COVID. So there are special causes and there are common causes of variation. Now, sigma is also known as the standard deviation. See, today, till now, we are discussing general topics, general terms and concepts about what is variation, what is DPMO. We are just focusing on them. And they will be used when we discuss the measure part and the analyze part. So sigma is also called the deviation or the standard deviation. Now look at this diagram. The center is the mean, the LSL, RSL or USL. If there were two lines, they would be on the both sides of the curve. This is a natural normal curve. In a normal curve, world is normal. Things are going smoothly as they go smoothly. Like for example, the weather conditions. We have got, at least in India, summer season, winter season, rainy season, etc. So four seasons in a country, or let's say two seasons, summer and winter. Now we have seen cases that in summers, suddenly weather changes. It starts raining and the weather becomes cold. A winter doesn't come at all. It still is very warm. So those are special causes. So they are, one is normally expected behavior. Okay. A normally expected behavior of a person or of a process. And then we know there will be a small deviation here or there. Once in a while, there will be variation. Now for large sigma, the data points are scattered much far from the mean. Like we saw in the runway experiment, if you the runway was horizontal. Now you consider that runway as vertical now. So lower limit, upper limit, two boundaries of the runway, and there's a mean. The target is always to be as close to the mean as possible, to be as close to center as possible. And then we say how many deviations are there on the left, right side of the center between the lower and upper specification limits. And what is beyond that is defective. We'll see. I know day one, these things will look slightly more complex, but they are not. Sherry, you have a question?
Sorry, no, I don't.
Yes, anybody who has a question, please. So our main aim is to reduce the variation. Okay, that is the whole purpose of Six Sigma, reduce the variation to make sure it is as close to the center or mean of the runway as possible. Now, this is true for every process. Every process, the more variation, that means more possibility of defects. Initially in the pilot 1, we saw in the case of this pilot, although it was between the limits, but there is a real possibility that the pilot may go beyond the boundary of the runway. Till now, it is okay, but chances are very high that he may overshoot or go more left or more right for whatever reason, and there will be an accident or a defect. Till now, there is no defect in the pilot A case, no defect at all. But chances are all there because of the erratic behavior. Now, if it had fallen beyond the runway, that would be a customer defect. Similarly, here also, when we say VOC, that is the voice of customer or the upper specification limit, USL. There will be a similar line on the left side also. On the both sides of the mean, there will be the voice of customer, that range he has given, which is acceptable. If something goes beyond that, is a defect, not acceptable. So our target is to reduce that variation to as less as possible in Six Sigma. We can see it also from some other angle. Z value is the sigma level. How many variations we can fit between around the mean, 1 sigma, 2 sigma, 3 sigma on both sides. That is our goal. The lower LSL and the upper SL, upper specification limit, which is the tolerable limit of tolerance. Anything outside that. So why should we behave in a manner where we are hitting the boundaries? Why not always target zero defect, 100% compliance, always at 9 o'clock, always center of runway? That is the target. So without going into semantics or formula or plus or minus sigma, if the goal is always zero defect, then we will be somewhere near that. We may not always hit zero defect. We may not always be centered around the mean, but we will be within the range. Right? That is the goal. We will see it when we actually start computing it. So as the deviation increases, the possibility of defects will also increase between the limits, and the curve becomes more flat. So we have to make the curve very, very straight, vertical, not make it flat. That means possibility of going outside the limits will keep on increasing. That is what Six Sigma is all about. How we can fit more number of standard deviations in those limits, lower LSL and upper USL. In black belt specifically, we target to hit the mean most of the times. Okay, maximum 3.4 defects outside the beyond the mean. So there are two variables, a dependent variable and independent variable. The dependent is computed, is the output of the process. You have to reach office at 9 o'clock. That is the output, that is the goal you want to meet all the times. But whether you reach on time at 9 o'clock or before or after 9 depends on the time you leave from your home. Depends on the kind of vehicle you take, on the route you take, etc., and the traffic conditions. So these are all X independent variables. The time you leave, the route you take, etc., these are all X variables, X parameters. And depending on the combination of these, you will reach the Y. Your time to reach office, which is Y, is dependent on these factors, which is the X factors, which are the causes, and the Y is the effect. So this
Excuse
formula, yes,
me, just
yeah,
a quick one on the previous
Yeah.
slide.
okay, yes,
Kindly shed more light on this interpretation of this graph, especially the comment that is there where you're saying as the standard deviation increases, the number of defects increases. Could you reference this to the previous slide where we have deviations 1 to 6 categories,
Okay.
so that we get a clear picture?
okay.
I think it is slide A, that's slide 20.
Let me focus on this.
This in reference to the other one above where we're selecting the deviations categories where we have 1 to 6.
Okay. Now question is, how many sigma is deviation and deviation, right? Now, how many deviations we can fit between the lower specification limit and the upper specification limit? Now, if the tail of this curve, let's say this curve, the gray curve, reaches the LSL and second tail reaches the USL, that means it is a standard deviation, just one deviation, which is covering the entire range between LSL and USL. Now, can we look at the number of this thing, 1, 2, 3, 4, 5, 6. Okay. On the right diagram, 6 deviations can be fitted and 6 on this side. These are the number of deviations we can fit between LSL and USL. Ideally, if it's only a single deviation, one deviation fitting the entire curve between LSL, SL, USL, that means one deviation, one sigma. And anything beyond that, which is we are operating on the boundary level. Now think of LSL, USL as the runway, boundary of runway. If the performance of the pilot is that he is touching both the boundaries, USL, LSL, then between a small deviation will lead to an accident or error. So we say how many deviations can we fit between the two boundaries of LSL and USL. The more number of deviations we can fit, that means higher the sigma level. If we have only one, let's go to next one. So goal is to make the performance as if between the LSL USL, the green one, the center one, the vertical hill or mountain or curve. If it is more centered towards center, so look at the green one. This is maybe 2 units, 2 here, 2 here, 2 here, on both sides. We can have 3 or 4 sigma fitted between the two boundaries. So if the deviation increases, the number of defects will also increase. The spread is increased. It has become more flatter. It can become even more flat and go here. So 20% this side, 20% this side. So as the number of SD increases, so we have to start to fit the deviation, more number of deviations within the two boundaries. Look at these lines, the dotted lines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. On both sides, we have got possible 6 deviations, but our actual findings are centered on the red line. This is the target, and most of the findings are only here. They are not scattered. So there is a margin on both sides. Even if it follows 2 deviations, 3 deviations, 4, 5, 6, still it could be within within the limits. If we are always targeting the center, so even if there are many more deviations we have on the left or right side, the actual performance would still be within the two boundaries. So one is the potential, one is the actual. Actual one is around the red. If this gray area or the curve was very flat, it would not have it would not have gone like this and here. It would have, sorry, it would have become flatter, and then it would have crossed the limits and come here and caused error. So we have to strive to be as close to the mean as possible so that more deviations can be fitted between the two limits. Now, one thing that happen is we can extend the limits. Let's say LSL, we stretch further to left, and this thing USL to right. In practical terms, if your office time is 9 o'clock, you are given margin of 15 minutes, 8:45 to 9:15. And so people try to, now instead of focusing on 9 o'clock, they will say, okay, we have got time till 9:15. And gradually they'll start overshooting that time also. Now the company can say, no, boss, this is a deviation, this is error. If you come after 9:15, you will be marked as absent. So or company can do, okay, I am giving now 30 minutes margin. Instead of 9 o'clock, there is flexi hour. You can even come till 9:30. You will be considered you are within time. So if the actual performance for people is 9 to 9:05, and now the margin is till 9:30, but you are focusing on 9 o'clock only. So 9 to 9:05 is the current performance. That means 5 minutes. Now, how many 5 minutes can we fit till 9:30? 6 times. 9:05, 9:05 to 9:10, 10 to 15, 15 to 20. 6 deviations can be fitted within that half an hour range. That is what we want to do. Focus on center and ensure that variation is so less that between the two limits, we can fit in many deviations, 3 deviations, 6 deviations, 5 deviations. Then we are a Six Sigma. But if we only have the current performance is, let's say 3 sigma, that means plus minus 15. That means you can have 9 to 9, 10, 10 to 20, 20 to 30. Only 3 deviations you can fit. Maybe we'll understand this better next in the next class, or when we do some practicals, when we actually start measuring the deviations. Okay. Now let us take a 20 minutes break, and then we continue with the lean part because we have a lot to cover. Is that fine? Yeah, Roberts,
Yes. For how long?
Yes.
20 minutes or half an hour?
Okay. Okay.
30 minutes
Okay.
break, right? 30 minutes break, and then we continue till the end.
That means we are resuming at 1.
30 minutes from now.
Okay. Thanks for the explanation. Is well understood on my side.
Thank you. So before this break, we spoke about sigma and variation and how our focus should be to reduce the variation so that every single time we follow the process, it is centered, it is around the mean. And how many, and there is but there will be some deviation in every single process. How do we reduce the deviation? So that if it is a 1 deviation, let's say, so between the lower and upper limits, how many more deviations can be fit? 1 unit, 2 unit, three on either side means 6 deviations. So if the deviation itself is very large, then even small deviation further means the more defectives are produced. The second term is the lean. Lean means without any waste. So this is the approach to business, which is based on the premise that anywhere work is being done, waste is being generated, and the business can be improved by the systematic elimination of that waste. It is very widely assumed and spoken about that 70% of the time we are waiting for something to happen. We send a mail to somebody and we start waiting for the person to respond. We send a message on WhatsApp. We start waiting, expecting the person will see the message, will send a reply. So 70% of the time goes in the wait stage or searching for things, searching for a pen or diary or something in the drawers, in a cupboard, in a home. So we are on all that is waste. So here when we talk about lean, we say we should identify and reduce the waste. So first is define what is waste, and then identify the sources of waste, and then plan for their elimination, and then establishing permanent control so that it does not happen again. It is like between correction and corrective action. When there is a defect, we correct it. But when we say corrective action, we look at the root cause to ensure that this thing does not happen again. So same way, we have to identify, remove the waste, but create a system to prevent it from collecting again. So the reduction and elimination of waste is the goal in lean philosophy. And Toyota introduced this philosophy as part of their TPS uh, before it became very uh, famous and became to be known as lean. Now let's look at the some more definition. Now, what are the different types of waste in the organizations? What are the different types of wastes in organization?
We have medical waste.
Medical waste, right?
Time waste.
Yeah, waste of time, right?
Waste of
In
resource.
manufacturing, I could look at process waste.
Yes, process waste. When we produce something and some defectives are produced which cannot be reworked or corrected, that also goes as a waste, as a scrap. So in terms of lean, these are different types of 7+1 waste. Waste is called muda in Japanese. Now it is anything which does not add value to the customer, from their perspective. If customer expects, let's say they buy a water bottle, they want a bottle which is made of a decent material, which does not, harm the water. It is biodegradable material, and the water is safe and drinkable. That is what they expect at a reasonable price. If you make a bottle which is very fancy, very costly, with diamonds around the bottle, it is not adding any value. The purpose of water bottle is to have a drinkable, ingestible, safe water at a reasonable cost, and then bottle should be throwaway bottle. So if you add all those diamonds and maybe a bottle case, everything, which is not adding to the experience of the customer, then all that is also waste, because they are paying for things which they did not ask for. It does not add to the drinking experience, quenching their thirst. So anything which from customer's perspective, which is not adding value, is a waste. A customer is only willing to pay for the transformation of the product or service, not for the time it sits on a shelf or the time a worker spends walking around. Internally, when we make something, we may be not very efficient. The way we structure the organization, one person this floor, second department, second floor, third floor, fourth floor. No, you keep walking around unnecessarily, which is also a waste of time and efforts and resources. So there are 7 ways we can remember that as Tim Wood: T for transport, inventory, motion, waiting, overproduction, overprocessing, and defects. So let us look at them one by one, each of these. Transport is unnecessary material movement of products, materials, or information from one place to another. Example I gave earlier, if you are filling a form for getting insurance policy, the policy details are filled at the local level, by the person who takes your details, enters into the form, and you also verify it, and both of you sign it. Then it goes to level 1, level 2, level 3, multiple departments, multiple offices, unnecessarily, because they don't add any value. At the first level, let's say my boss checks it, if I am the insurance agent, and he will verify that all the contents are correct, spelling mistakes, and all the mandatory fields are filled. Thereafter, there is nothing else required. It will go to multiple local, regional, central office, and people are there only just signing it, and that is it. But it adds to the waste of movement. So bad example of this is storing incoming goods in a temporary receiving dock, moving them from forklift to some other storage area, again bringing them back next day, packing station. No, unnecessary. The way we structure the office and the workflow, it should be very seamless and smooth with minimum back and forth. I remember earlier in the banks, it used to happen. The way they were structured and the different desks were operating, person would take your check, verify some details, and then it will be lying in a basket. A peon or a support staff will come, pick the basket, take to some other random window far away. There, somebody else will check it, goes to third place, then it comes back again to the first point. No, and they're waiting for the person who will come pick the basket with all the checks every 15 minutes, and then keep on rotating them. So four, it goes to first, second, third, again first person for payment of the money. But the way these different stations were located, first to second, second to third, third to again first, and they were at a very far distance, all wasting time. But these days now it has changed. They only work between two people who are sitting next to each other. So I process a check, give to my neighbor, and he will or she will process it, give it back to me by hand. So we are adjacent to each other now. So instead of having the office staff sitting all across the floor, now it is the way they are seated is next to each other, minimum movement, and only in two steps the whole transaction is over. Or again, same example of office, emailing document to three people for review sequentially first, second, instead of marking to everybody for and then also having a SLA that if within 10 hours or 24 hours it does not uh, return with approval, then it is deemed to be approved. Okay, because people are traveling, they may be busy, not able to see the mail and respond. So within 24 hours or 2 days, the person does not respond, that means take it as approval, and so on. So transport is one unnecessary type of waste. The second is the inventory. Having more raw materials, work in progress, or finished goods than you need right now. So your cash is tied up, you got a whole storage space all locked up because of inventory, which is not getting sold. And you want to buy more material, no space to keep them. A clothing store, for example, buys 1,000 winter jackets in August based on a guesswork, and then they have to pay for the storage, and they are left with the dead stock if the winter is warm and people don't buy those jackets. We buy a printer cartridge with a 5-year supply. It takes up space, and the cartridge might dry out, and the money is now spent now instead of later. There are times when there is a sale during winter, during Christmas and other places, other times. So because of discount schemes, we end up buying more stuff, and it is just tying up our money. It's lying somewhere in the cupboard or shelves and not used forever, ever in life again. So first is transport, wastage in transport. Second is the waste of inventory and the holding area and the storage cost. The third is motion, unnecessary movement of people or equipment, walking, bending, stretching, searching that exhausts workers and slows down the process. When there is a bad filing system, For example, think of simplest example in your mailbox. If you do not have smaller mailboxes and folders and subfolders where you make where you keep all the material in right appropriate folder. If you have to search for something, you straight away go to that folder or subfolder, you'll find a document. But when that filing system, either in mailbox or in real life, physical life, is not done, then we keep on searching for things. We keep searching because the way we store them, labeling and all, is not done properly, leading to a lot of movement of people where they are going around, opening desks, going to this room, that room, searching for things. The extra motion. So worker, for example, has to walk 15 steps to a shared tool cart to pick up a screwdriver for every single product they assemble. Because the storage, the way they have stored all these typically normally used tools is in a central place. So they have to go, pick it up, use it, again, keep it back. Or a shared printer. Every time you file a printout, you have to go all across the floor to a corner, pick up the paper and come back. So this is extra movement. So this is all waste. We have to identify what are the wastes in our organization, waiting for things to happen. Idle time and people, equipment or information is not ready. So this is most frustrating. A patient arrives for a 10 a.m. appointment. Wait for this one. The doctor is running behind because of paperwork issues. Patient waits for 45 minutes. The bad planning. You give appointment to a patient for 10 o'clock. The patient arrives at 10, but there are more patients waiting in the lobby. So your turn comes at 12. Very, very frustrating. Same factory example, machine is idle for 30 minutes while the waiter is operating for technicians to come fix a simple jam, etc. So these are all waiting. Waiting is one of the worst cases which happens in organizations. The overproduction, like somebody said, we make more of something or make it sooner than the customer needs. And that leads to most other waste because it is all adding up. Then it's a restaurant, people know that typically what is the number of burgers being sold or food item being sold during lunch. So by 12:30, only 30 have been sold out of 50. So you had them pre-cooked or half-cooked in anticipation that there will be a lot of customers, and the customers do not turn up in those numbers. So remaining are become bad and they have to throw away. So overproduction, printing 50 copies of a 100-page document, presuming that there will be 12 people attending a meeting, only half of them come. All remaining is all printout done and lying somewhere, and then they are sold as garbage. Similarly, over-processing, doing more work than the customer requires or is willing to pay for. For example, the example I gave of the water bottle, pushing the inside of a metal tube to a mirror finish when the tube is going to be buried underground. But doing extra work on the machine, on the process, which is not adding any value because you feel good about it. But the customer wants a basic core product. They are not willing to pay for extra jing bang or cosmetics or look and feel factors which you have put on the product or service. So do what is adding value and the customer is willing to pay for that, pay for. Not because you feel it is good and useful and it will make it more attractive. Same like a hotel employee, decorating all those things on the table, which are not adding value. And then the defects which we create. This is typical when we create those mistake or work in progress, defective products or services, we have to just scrap them and sometimes rework or sell at a discount So all that money is waste. A smartphone screen has a tiny scratch during assembly. It can't be sold as new. So either you take it apart or replace it or sell at a discount. So all these are defective products, which are basically waste for the organization because customer will not take it. And then the last extra one is the eighth one, non-utilized talent. You hire a person, they're capable of much more things, but you use them for a underperforming task, less for tasks for which less competent person who could be paid less could be hired. You are hiring over talented person and then underusing him, underutilization. So all these are different ways, and the Lean Sigma talks about identify those ways and try to reduce them. So not only make a process uh, more consistent, which is Sigma part. Also, internally, when you're focused internally, you have to be more efficient, use optimum resources, men, machine, material, method, so that there is no waste and you're doing it right the first time, every time, using minimum resources, minimum time, with no wastage at any stage of any time. So lean is a bottom up, where we are looking internally within the organization. Six Sigma is top down, where we start from the customer. The customer is at the top of the hierarchy. We start with who is the customer, what do they expect, and from there we work backwards to identify areas where we can improve value for the customer uh, and be consistent in our output. But Six Sigma has two methodologies, DMAC, which we'll talk about, and DFSS. The DFSS applies DMA/DB, which is for new processes, new products, new areas where we have not made anything till now, but we want to be preventive in our approach. We try to minimize defects, minimize delays, minimize waste. So from before we start anything, we start following a Six Sigma method. So this is very rarely used. What is majorly used is DMAC, which is for things in operation, existing processes, and then we try to improve them. This is where it is used mostly. So DMAC improves existing broken processes, whereas DFSS designs new high performance processes or products. So DMAC is reactive, whereas DFS is proactive before we do something. So DMAC follows that DMAC phases define, measure, analyze, improve, control, and DFSS often uses DMADB. DMAC yields quick results, 3 to 6 months, while DFS takes longer to deliver long-term results. We have made something based on Six Sigma. We do not know it will work or not work. It's only when we finally produce something, it goes to market, then we know whether what we have done is good enough as per the customer expectations. So it takes much longer time to hit the market. So DMAC is used when the process exists but is failing to meet specifications, while DFS when a process does not exist or a major redesign is needed. So this is same thing again in a graphical format. So DMAC phases are define, measure, analyze, improve, and control, and then institutionalize. Because when we pick up a project for improvement, any process for improvement, we take it as a pilot. It does not currently impact the normal working of the organization. It keeps on happening as it is happening. So this sample pilot case we take, we define it, see whether it's working or not. And when we find it is working, it is useful, much better than the previous process, then we introduce it in the organization in a controlled mechanism and then becomes available company-wide. So define the problem, measure the current performance, analyze the root causes, improve the performance by identifying the best causes, solutions, and control the changes so that the problem will not occur. So there will be monitoring for some time that the new model introduced, a new process introduced in the organization is working. That is the control part. For a few months we monitor it before we are assured of the process working and improving things. So this is the whole Six Sigma in the Six Sigma process or method, which is again common sense. Know your problem, know where you stand, the magnitude of it. It's like a doctor, before you go to doctor for some illness, let's say fever, you will tell him, oh, I have a fever. So he will say, okay, run these tests, temperature, many more pathological tests. Only when the tests come, they will know what is the problem. So measure part is getting to do all those tests on the patient before they can know whether it is a typhoid or a viral fever or some other form of local disease. Before that, they cannot give a treatment. So know the problem, measure the current issues, then analyze the root causes, and then give best medicines.